In this unit, we're discussing the date picker control, which, in my opinion, is one of the most complex ARIA controls. In the section introducing the component, we'll walk through at a high level and explain how all the components fit together with established keyboard navigation patterns. We'll also discuss its anatomy and what elements it's built from. In experiencing the accessibility gap, it's centered on helping you understand the accessibility gap of the control with no ARIA. Using the NVDA screen reader, you'll hear what's missing when the control is navigated and understand how missing these critical attributes affects the user's experience. We'll begin to break the component down into sections in identifying the component parts, the HTML structure, and ARIA semantics, giving us a blueprint to work from. We'll discuss what keyboard event handlers need to be created. We'll begin wiring up ARIA roles, relationships and state in the section implementing ARIA, so assistive technology sees one coherent control, not unrelated elements. We'll discuss the keyboard navigation and lock in the expected rhythm in implementing keyboard behavior, using tab, space, enter, arrow keys. There's a lot to unpack, all to move through the date button, date picker and date grid. After adding all the required behavior, we'll show how this all flows through when navigating with the NVDA screen reader in improving the screen reader experience. This is the after demonstration, our finish line. This will help you understand what's been added and the improvements made to the screen reader experience. We'll also step back and ask whether a date picker is actually needed. An accessible date picker can be a useful pattern, but it still needs to solve a real user requirement rather than adding complexity for the sake of it. There's a lot to unpack. If you're ready, let's get into it. But what is a date picker control? As the name suggests, it's a control that lets a user enter or select a date. It combines a text input with a button that opens a calendar panel. The calendar presents dates grouped by month and year with controls to move through those months and years. Selecting a date updates the input with the chosen value. The most common date picker variant is one that allows a single date to be selected, but there are other variants that support date ranges, disabled dates, or separate month and year selection. This pattern has a text input for the date value with the ARIA attributes. ARIA has pop-up, ARIA expanded and ARIA controls, providing semantic behavior, state and linkage. A button opens the calendar picker and uses ARIA label for labeling. Describing the required date format guidance is programmatic, using ARIA described by on the input, so users know the expected date format. The calendar opens in a dialog container using role dialog with ARIA modal true. The dialog has an accessible name provided by ARIA labeled by, referencing the visible month and year heading. The calendar is built as a table with rolled grid. The grid contains rows for each week, column headers for the days of the week, and individual cells for each date. The selected date is communicated with ARIA selected. Month and year navigation is handled by buttons inside the dialog. Using these buttons, update the visible calendar dates. This is placed in an ARIA Live region and keeps screen reader users informed when the displayed month changes. The control effectively manages focus. Opening the date picker moves focus into the dialog, usually to the selected date if a previous date is entered or today's date. Arrow keys move focus through the date grid, while tab moves through the month and year controls in the dialog. Selecting a date updates the input value, closes the dialog and returns focus to the calendar button. Without ARIA, a date picker conveys extremely limited information to a screen reader. Whilst the input, calendar button and date grid appear to work visually, much of the structure is only shown on screen. The screen reader announces an edit field and a button and may announce a series of dates, but it doesn't clearly communicate that the button opens the calendar dialog, what month is currently being displayed, which date is selected, or how the dates relate to the input. But let's try the date picker out in this example without any ARIA attributes. In this scenario, the user tabs to the date picker and navigates through dates.
Landmark, main landmark, document, Appointment date edit selected 0. Calendar button. Button, 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 today button, cancel button, OK button. Button cancel, button today, table with 7 rows and 7, FR column 6 clickable, TH column 5 clickable, SWE column 4 clickable, 5. 2 column 3 clickable, 4.
From the example, there's no clear indication of what the date picker control is doing. We don't know whether the calendar is available, whether it's open or closed, or how to select individual dates. Pressing tab still moves through the input and button because they are natively focusable elements, but the semantic structure of the date picker is incomplete. It's missing the ARIA attributes that explain the pop-up relationship, the expanded state, the expected date format, and the selected date to a screen reader user. In short, it's unusable and it's broken. What makes the component to tick is a combination of the JavaScript used for event handlers and the functionality to power the date picker control. ARIA attributes, some static and some dynamic to describe the state and relationship, and a skeleton of semantic HTML comprising input, heading, buttons, and table forming the main structure of the control. The ARIA attributes required to change these elements into a functioning date picker control are, for the date input, ARIA label to provide a programmatic label to the input if no visible label is used. ARIA describe by to associate the input with the visible date format instructions, making the expected format available to assistive technologies. ARIA has pop-up to create the dialog semantics, and ARIA controls to programmatically link the input to the dialog. For the calendar button, ARIA label to provide a clear, accessible name for the button. For example, this could be choose date. The ARIA label can be updated after a date is selected to include the chosen date, such as change date and, for example, 24 June 2026. On the dialog container, roll a dialog to identify the calendar picker as a dialog. ARIA modal true to communicate that interaction is currently contained inside the dialog. And ARIA label or ARIA label by to provide an accessible name. For the month and year heading, ARIA live polite, so changes to the month and year are announced when the user navigates through the calendar. For the calendar table, roll a grid to identify the whole calendar table as an interactive date grid, and ARIA label by to programmatically associate the grid with the visible month and year heading. And for the individual date cells, ARIA selected true to identify the currently selected date. Tab index 0 on the active date only, so it is included in the tab sequence, whilst tab index -1 on the other date, so they can receive keyboard focus through the keyboard interaction without all dates being added to the tab sequence. JavaScript then updates these values as the user opens the date picker, moves through the calendar, changes month or year, selects a date, closes the dialog, and returns focus to the calendar button. This is where we begin providing the structure of the date picker. Let's jump into the code. The date input doesn't require an ARIA role because it uses the native HTML input element. And that's the same for the calendar trigger button. It uses the native button element, so the role is automatically provided. The calendar pop-up uses roll a dialog. This identifies the date picker pop-up as a dialog element rather than ordinary page content. The calendar table uses roll grid. This changes the semantics from that of a data table to an interactive grid where users can move between dates. And that too is the same for the day column headers. Because the native table is used, the table headers provide the column header structure. If the calendar was built with non-semantic elements, each day header would need roll column header. As a native table is used, the table rows provide the calendar row structure. However, if the calendar was built with div and span elements, each row would need roll row. And once again, the native table cells provide the date grid cell structure. If the calendar was built with non-semantic elements, each date cell would need roll grid cell. Modern web apps often need more than native HTML, but once you start building custom components, it's easy to get ARIA wrong. What role should the component have? What states need to change, and how should focus move? If you've ever copied an ARIA pattern and hoped it was right, you're not alone. That's why I created my course, Advanced WCAG Accessibility, Master ARIA Component Patterns. You'll learn how ARIA really works by breaking components down into roles, states and properties, all with expected keyboard behavior and focus management. We'll use practical examples, demonstrate before and after with the screen reader testing and runnable code demos. You'll get to not only understand what needs to happen, but experience it. You can see what changes in the code and what changes for the user. By the end, you'll be able to build modern, progressive components like combo boxes, tabs, dialogues, and date pickers with more confidence, using patterns directly sourced from the W3C ARIA Authoring Practices guide and applying them in a practical, implementation-focused way direct into your projects. This course is for anyone who wants to stop guessing with ARIA and start understanding what their components are actually communicating. Start building advanced ARIA components with confidence. If you think that's you and you're interested, check out the link in the description below. The calendar button uses ARIA Expanded to communicate whether the date picker is open or closed, and this is toggleable. When the calendar dialog is hidden, ARIA Expanded is set to false. When the calendar dialog is opened, JavaScript updates this value to true. This communicates the button controls a pop-up interface that has changed state. The selected date is communicated with ARIA selected true. This is applied to the date that matches the current value in the input. When the user selects a different date, JavaScript removes ARIA selected from any previous date and applies ARIA selected true to the newly selected date. And for unselected dates, all this happens in reverse, but with one caveat. Dates that are not selected don't need ARIA selected false. The absence of ARIA selected communicates that those dates are not currently selected. This keeps the selected state focused on the one date that has been chosen. If some dates can't be selected, they use ARIA disabled true. This communicates that the date is present in the calendar but unavailable for selection. JavaScript must also prevent the disabled date from being selected, so the visual state and programmatic state remain consistent and in sync, and all these states are dynamically changed as the date picker changes. The date input uses ARIA described by to programmatically link the input to the visible date format. ARIA has pop-up is set to dialog, and ARIA controls references the dialog by ID, connecting programmatically the input with the dialog. ARIA label is applied to the calendar button, which in most implementations is represented as an icon. This gives the button a clear, accessible name, such as choose date. Whenever a date has been selected, we can also update the ARIA label to include the selected date and a short instruction to change the date, such as change date 24 June. The date picker dialog has a programmatic name provided by ARIA labeled by, referencing an existing heading. You could also use ARIA label. Whichever technique doesn't matter as long as the labeling is applied. That's the important point. This is followed by the attribute ARIA modal true, which describes the modality when the date picker opens. This communicates that the user is inside the date picker dialog and that the rest of the page is inactive. The visible month and year heading use ARIA live polite. When the date is refreshed, such as selecting another date, JavaScript updates the text, triggering the live region to keep the user informed of date change. The calendar grid uses ARIA labeled by, with the value being the ID of the visible month and year heading. This gives the grid an accessible name based on the currently displayed month and year. Much like the calendar button, if the month and year navigation buttons are icons or symbols, ARIA label is applied to each to provide an accessible name, such as previous month or next month. Keyboard help text is contained inside the date picker using ARIA live polite. This allows instructions for navigating the calendar grid or any other announcement related to the date picker to be announced when needed, without adding those instructions statically to every date cell. Depending on the design, it can be visible to all or remain just as a live region hidden visually. You need to decide though, would all users benefit from seeing those instructions? Keyboard interaction for a date picker is more involved than simpler controls because focus needs to move between the text input, trigger button, calendar dialog, and the dates inside the calendar grid. The only controls that remain in the normal page tab sequence are the input and the buttons. All other navigation is using arrow keys, page up and down, left and right, and enter and space. Enter or space on the calendar button opens the calendar dialog, toggling the ARIA expanded attribute from false to true. When focus is inside the date picker dialog and escape is pressed, the dialog is closed without changing the selected date, with the ARIA expanded attribute toggling from true to false. Tab moves between the next and previous month and year's buttons inside the open date picker, whilst Shift Tab moves backwards through those same buttons. Once focus is inside the calendar grid, the date picker needs additional keyboard behaviour. The arrow keys move in the direction of the key press. Right arrow key is one place to the right, left one place to the left. Same for the up and down keys. The only attribute that changes is tab index, changing from -1 to 0 when a grid cell has keyboard focus. The movement and changes are similar when home and end are pressed, except this time home moves focus to the start of the week, whilst end moves focus to the end of the week, each time changing the grid cell tab index from -1 to 0. The page up and page down keys navigate months. Page up for previous month, page down for next month. And because the month is within an ARIA Live region, the updated month and year is announced to screen reader users. As before, tab index 0 is moved to the equivalent focus date in the newly displayed month, with other dates setting tab index -1. The shift and page up and down keys navigate years. Shift plus page up for previous year, shift plus page down for next year. And much like the month navigation, because the year is within an ARIA Live region, the updated month and year is announced to screen reader users. Now that was keyboard navigation. For selection of dates, when enter or space is pressed, the focus date becomes the selected date. The newly selected date toggles ARIA selected true. A previously selected date has ARIA selected removed. The input value is updated with the selected date. The calendar button label can also be updated, so it changes from choose date to something more specific, such as change date 24. The dialog closes. ARIA expanded on the calendar button is toggled from true to false, and focus returns to the calendar button. Arrow key behavior is central to the date picker because the calendar is presented as a grid of dates. The user must be able to move through days, weeks, months, and years without tabbing through every individual date. Extra behavior beyond the setting and updating of ARIA attributes is required for the date picker control. We've covered the essentials for the date picker, but your implementation may also require extra buttons. For example, OK to confirm a date and populate the input, and cancel to return focus to the input. You may also require a dismiss X in the top right of the date picker. You can now begin to see, even without this extra behavior, there's already a lot of complex functionality. Adding more features makes it more interactive, but also makes it more brittle, as it's easy to forget to update a navigation path. And this is even before we discuss the cognitive load placed on a screen reader user. Adding more functionality means the user needs to do more and understand more. For simple date entry, like a date of birth, is this control complexity needed? Or can a text input perform the same action with far less user friction? Now, I can't answer those questions for you, but I have provided several blog articles that discuss the topic further. Just because a date picker can be programmatically created following the required ARIA behavior, it doesn't necessarily mean it's accessible. Some users will encounter difficulties, so I challenge you. Question: do you need to use an ARIA date picker control? Now let's revisit the date picker control example, and after adding the attributes and JavaScript event handlers. Once again, in this scenario, the user tabs to the date picker and navigates through dates.
Main landmark, document, appointment date edit use format dd/mm/yyyy. Choose date button collapsed opens dialog. June 2026 dialog. June 2026 table. Monday, June 15, 2026 row 4 MO column 2 current date. Today button. Cancel button. OK button. Button cancel. Today button. June 20. Monday, June 8. Monday, June 1st. Tuesday, Wednesday, Thursday, June 4th, 2026 row 2. Thursday, June 18th. Button
Now the date picker exposes its structure and state more clearly to assistive technologies. The user can hear that the date field has an associated calendar, understand when the calendar is opened, and identify important date states like the selected date, today's date, and the focus date. These audible cues help a screen reader user understand how the date picker works in a non-visual way. However, ARIA only communicates meaning and state. The keyboard behavior and selection logic still need to be added separately, and different screen readers may announce different levels of detail. After completing this unit, you should be able to explain in plain language what a date picker control is and how the date input, calendar button, dialog, and calendar grid work together to help a user choose a date. You can describe the core anatomy of the pattern, including the labeled date field, the button that opens the calendar, the dialog container, month navigation controls, and the grid of available dates. You can demonstrate the accessibility gap by predicting what a screen reader user may miss when the date picker's structure, state, and relationships are not exposed correctly. You can implement the essential ARIA attributes and states, including ARIA has pop-up, ARIA expanded, ARIA controls, ARIA labeled by, ARIA modal, ARIA selected, ARIA current, and explain what each one communicates. Finally, you can implement and justify the keyboard model, including tab to move through interactive controls, arrow keys to move between dates, enter or space to select a date, escape to close the calendar, and our focus, state, and the selected date update together. In this unit, we took a date input to calendar button, dialog, and date grid and turned them into a working date picker control, starting with what doesn't work, then layering in what does. We experienced the accessibility gap by demoing the no ARIA version in NVDA, where the calendar relationship, selected date, current date, and focus date were not clearly communicated. We connected the parts of the control by adding the required structure, relationships, and states, including the labeled input, calendar button, dialog, grid, selected date, current date, and disabled dates where relevant. We established the expected keyboard behavior, including tab to move between interactive controls, arrow keys to move through dates, enter or space to select a date, and escape to close the calendar. The result is a more accessible, screen reader friendly date picker control where focus, selection, visibility, and date state work together. Now it's your turn to jump into the code example. Start with the before version where the date picker works visually but is missing the ARIA attributes needed for screen reader users. Use the prompts in the code to add what's required, then compare your work with the after version. Test opening and closing the calendar. Does ARIA expanded update? Is the pop-up correctly connected? Is the date format announced? Is the selected date communicated? Then test the keyboard behavior. Can you move between dates with the arrow keys? Select a date with enter or space and close the picker with escape. Try it with NVDA and listen to how the input, button, calendar dialog, and selected date are all announced. There are also stretch goals and a knowledge review to help reinforce what you've learned. Good luck.